Okay, so welcome to the next installment of example problems. So here we've got a baby blue jay sitting on a tall tree awaiting the arrival of dinner. As the mother lands on the nest, she drops a worm toward the hungry chick's mouth, but the worm misses and falls from the nest to the ground in 1.5 seconds. How high is the nest? So let's read it again, get the better gist of it. A blue jay sits on the tall tree awaiting the arrival of dinner. As the mother lands on the nest, she drops the worm toward the hungry chick's mouth, but the worm misses and falls from the nest to the ground in 1.5 seconds. How high is the nest? Since it's an acceleration problem, because it's a freely falling object, we will have to use 5 columns and 2 rows. So let's go ahead and get that going. So we'll come along here. 1 column, 2 columns, 3 columns, 4, 5 columns. So displacement, time, initial velocity, final velocity, and acceleration. Displacement is what we're trying to find. Actually, we're trying to ask how high it is, but we have to solve for the displacement. We have a time of 1.50 seconds. There's 3 significant figures there. The initial velocity of the worm is 0, and the acceleration is negative 9.8 meters per second squared. Velocity final, the final velocity does not participate. So then you look at your list of equations and you say, aha, I know which one. And that's going to be the displacement is equal to the initial velocity times the time plus 1/2 AT squared. Since the initial velocity is 0, get rid of it. Initial velocity is 0, we don't need it. And now this equation simply becomes 1/2 AT squared. We can now put the values in. We see that we've got those, and then the displacement is equal to 1/2 times negative 9.8 meters per second squared. I don't like that. There we go. And we have a time then of 1.5 seconds. Square that. And we have then, do all the little punching into the calculator, we end up with negative 11.003 meters, I believe. Since we only need 3 significant figures, we'll report this as a displacement of negative 11.0 meters. Now, that 11.0 meters is the displacement, because the worm fell from our diagram over here that I did not draw, but you can see that it is drawn, fell in a negative direction, and that's consistent with with our answer. But the question is asking how high is the nest. That's a distance, so we're not interested in the direction in this case. So the answer is, it's a bad D. The answer is 11 meters. Done.